Unit 1, Force and Motion. Lesson 2, Graphic representation of moving in a straight line. First question, give reasons for. Physicists use graphs and tables to represent the relation between variables. This is due to the following three reasons. Number one, to predict the relation between certain physical quantities, because it is much easier to see from the graph what is the relation between variables. Are they inversely or directly proportional? The second reason is to understand the practical results. By graphing the results between physical quantities, we can understand the practical data. Finally, to describe physical phenomena in an easier way, because it is much easier for some people to read graphs other than any form of data representation. We will talk about graphic representation of regular or uniform speed. We have three graphs we have to understand, draw, and even describe. Graph number one, which is called the distance time graph for regular motion at constant or uniform speed. So this is called distance time graph for an object moving with uniform or constant speed. As we can see, we have y-axis, which represents the distance in meter, and x-axis, which always represent time in seconds. And as we can see, as time increases, the distance also increases, so they are directly proportional. Also, by increasing the time, the distance also increases by an equal values. So to describe this graph, we can say that it is represented by a straight line passing through the point of origin. And it is represented by a straight line because the object is moving with constant or uniform speed. The second graph is called the distance time graph for an object at rest. At rest means it doesn't move. Its velocity is zero. So we have distance in meter over the y-axis, time in seconds over y-axis, over x-axis. So as we can see, as the time increases, the distance remains constant. This is because the object is at rest. So to describe this graph, we can say it is represented by a straight line parallel to the time axis. The third graph is called the speed time graph for regular motion at constant or uniform speed. So the first and the third graph representing an object moving with constant speed. But the first graph is called distance time graph and the third graph is called speed time graph. So over the y-axis we will write speed in meter per second, and as usual over x-axis we will write down time in seconds. As we can see, by increasing the time, the speed remains constant. This is because this object is moving with constant speed. And to describe this graph, we can say it is represented by a straight line parallel to the time axis. Acceleration. What's meant by acceleration? Acceleration, it is the change of an object's speed in 1 second. From the definition, we can conclude the mathematical relation that we can use to find the acceleration. From the definition, acceleration equals delta V over delta T, or the change in speed in 1 second. For example, if we have a car, this car moved from point A to B, and we measured its speed at A, and we will call it V1 equals 60 meters per second. Then we measured its speed at B, and we will call it V2 equals 80 meters per second. This car moved from point A to D during 1 second. So from the definition, to calculate its acceleration equal delta V over delta T. Delta V means V2 minus V1. We will call V2 the final speed, V1 initial speed. The final speed was 80 minus 60 over 1 second. So in this case, the acceleration equals 20 meters per second squared. And this is the measuring unit of acceleration, meter per second squared, as we will say later. Types of accelerations. We have two types of acceleration. The first one is called positive acceleration or accelerating motion. And this occurs when the object speed increases as time passes. And this occurs only when its initial speed, or V1, is less than its final speed, V2, or when V2 is greater than V1. Example, if we have a car, for example, and its initial speed is 20 meters per second, and its final speed is 40 meters per second, as you can see, V2 is greater than V1. So the type of acceleration in this case is positive acceleration or accelerating motion. This is because its final speed is greater than its initial one. The second type of acceleration is negative acceleration or decelerating motion. And this type of acceleration occurs when the object speed decreases as time passes. And this happens when its initial speed, or V1, is more than its final speed, V2, or when its final speed is less than its initial speed. For example, if we have a car, its initial speed is 100 meters per second, its final speed is 30 meters per second, then this acceleration is a negative acceleration or decelerating motion. This is because its final speed is less than its initial one. This happens when a moving car and the driver pressed the brake, so the speed of the car decreases gradually until it may stop. Note the following. The measuring units of acceleration are meter per second squared or kilometer per hour squared. If the body starts motion from rest, so its initial speed, or V1, equals 0. So when we see this word, an object moved from rest, this means that its V1, or initial speed, equals 0. When the car is moving, then the brake is applied, so its speed decreases. So its final speed, or V2, is less than its initial speed, or V1, and may reach 0 if it is stopped. And the type of acceleration in this case is decelerating motion or negative acceleration, when we see this word brake, or when its final speed is less than its initial. Uniform acceleration. What's meant by uniform acceleration? It is the change, whether increase or decrease, of the object speed by equal values through equal periods of time. For example, if we have a car, this car moved from point A to B. Its speed during passing through point A was V1 equals 60 meters per second. Then we measured its speed when it passed by point B, and we will call it V2 equals 80 meters per second. it covered this distance in 1 second. Then this car moved from B to C, and its speed at C is V3 equals 100 meters per second. And it covered this distance during 1 second. As we can see, the change in the speed during the first interval is 20 meters per second, and this change occurred during 1 second. Also, during the second interval, the change in speed is also 20 meters per second, and also this change occurred in 1 second. So this car is moving with uniform acceleration because it covers equal, because the object speed, it changes by equal values through equal periods of time. In our case, 20 meters per second each 1 second. Each 1 second. Graphic representation of regular or uniform acceleration. We just talked about graphic representation of uniform speed, and we studied 3 graphs. We will also do the same for uniform acceleration, and we will study also other 3 graphs. The first graph is represented by speed in meter per second over y-axis, and as usual, time in seconds over x-axis. As we can see, by increasing the time, the speed decreases. This means that its initial speed is more than its final. So this object moves with decelerating motion or negative acceleration because its speed decreases gradually. This occurred in a car, for example, when the driver pressed the brake. The second graph is between speed in meter per second over y-axis, time in seconds over x-axis, and it is represented by a straight line passing through the point of origin. This means that by increasing the time, the speed also increases gradually. This means that this object moves with accelerating motion or positive acceleration. The final graph we studied before in the 3 graphs for uniform speed is between speed in meter per second over y-axis and time in seconds over x-axis, and it is represented by a horizontal straight line parallel to the time axis. This means that by increasing the time, the speed remains constant. This means that this object moves at uniform speed or constant speed, and also it means that its acceleration equals 0. Acceleration equals 0 means that its speed is constant. Let's solve some problems. Problem number 1. If a car moves on a straight line, its speed changes from 10 meters per second to 30 meters per second within a period of 4 seconds. What is the amount of acceleration? First, we have to write down given to make it easier. Its speed changed from 10 meters per second, this is its initial speed, so v1 equal 10 meters per second, to 30 meters per second, this is its final speed, or v2 equal 30 meters per second within a period of 4 seconds. This is the interval or time, so delta t equal 4 seconds. Acceleration is unknown, we can calculate it from our magic triangle. From the magic triangle, acceleration equal delta v over delta t, or v2 minus v1 over delta t, equals 30 minus 10 over 4 equals 5 meters per second squared because this is an acceleration. And the type of this acceleration is positive acceleration or accelerating motion. The second problem, car A starts movement from rest. This is an important word. And then its speed increases to 60 meters per second through 5 seconds. This for car A. We have another car, while car B starts movement from rest, then its speed increases to 80 meters per second through 10 seconds. Which of the two cars is moving at greater acceleration? First, we have to solve for car A. We will write down its given. Its initial speed is 0 because this car moved from rest. Its final speed V2 is 60 meters per second. This change occurred during 5 seconds. We can calculate its acceleration. Acceleration equal delta V over delta T equals V2 minus V1 over delta T equals V2 minus V1 over delta T equals 60 minus 0 over 5 equals 12 meters per second squared. So this is the acceleration of car A. Let's find the acceleration for car B. It's given. Its initial speed is 0 also because it started also from rest. Its final speed is 80 meters per second. This change occurred during 10 seconds. So this is delta T. To find its acceleration equal delta V over delta T equals V2 minus V1 over delta T equals 80 minus 0 over 10 equals 8 meters per second squared. So now we can compare between their accelerations. And as we can see, car A moves with a greater acceleration than car B because car A moves with acceleration of 12 while car B moves with acceleration of 8 meters per second squared only. This is the magic triangle that we used to calculate this problem. The third problem, if a car moves at 60 meters per second, then after 3 seconds its speed becomes 30 meters per second. This means that its speed decreased. And it stopped after another 3 seconds. So it took about 6 seconds to stop. Calculate the acceleration by which the car moves. Mention its kind and represent this graphically. So we have 3 requests. First, we have to calculate the acceleration. Second, we have to mention its type. Third, we have to represent it graphically. We will calculate the acceleration during the first 3 seconds. During the first 3 seconds, its initial speed is 60 meters per second. Its final speed decreased to 60 meters per second. This change occurred during 3 seconds. We can calculate its acceleration. Acceleration equal delta V over delta T equal 30 minus 60 V2 minus V1 over 3 seconds equal negative 10 meters per second squared. So this acceleration is negative acceleration or decelerating motion. During the second 3 seconds, its initial speed is 30. 30 was the final speed during the first period, but it is the initial speed in the second period. And its final speed is 0. This is because he told us it stopped after 3 seconds. And this change occurred during 3 seconds. To calculate this acceleration equal delta V over delta T equals 0 V2 minus 30 V1 over 3 equal negative 10 meters per second squared. This means that this car is moving with uniform acceleration. Sorry, this means that this car is moving with uniform deceleration. And I said deceleration because it is a negative acceleration. The car moves with uniform deceleration or negative acceleration. The final request is to represent it graphically. If we draw the y-axis and x-axis and we put speed in meter per second over y-axis, time in meter per second, time in seconds over x-axis, we will see that at the beginning of the time, which means that at time equals 0, the speed was 60. After 3 seconds, the speed decreased to 30. After another 3 seconds, which means after 6 seconds, the car stops or the speed is equal to 0. So we can join these 3 points A, D, and G. We will get this straight line, which indicates that as time increases, the speed decreases. This is because this car is moving with negative acceleration. This is the end of lesson 2, unit 1, first term.